35. No, I didn't record that cute little song. Sorry. Polar coordinates that are given. Okay, this is polar. I want it rectangular. You guys know how to graph polar. Pi over 3 is right about there. And then if I go out 2, we'll put a point right about there. Out 2 from the origin. That's the nice thing about polar coordinates. Always going through the origin. Like if we draw a line that goes... Anyways. So if we want polar or rectangular coordinates, let's think about that for a second. This represents the radius, right? That's 2 out. 2 radiuses out. Oh, that's a great circle. Okay, so this would be 1. That's 2. Okay, so... and when you guys did vectors and you had a unit vector that was like right here, what did you have to do to make it go all the way out to here? You just had to multiply it by a scalar, right? Right. Okay, so we have an angle. So what would that unit coordinate be? Like just one unit out from the origin. 1/2. Ooh, you guys are good. So it'd be cosine of pi over 3 and sine of pi over 3. Right? But we don't want to just have a radius of 1. We want to have a radius of 2. And so we multiply it by 2. So what is cosine of pi over 3? That is 1/2. What is 1/2 times 2? And then sine of pi over 3, that is rad 3 over 2, but times 2. So what do we get? We get uno and rad 3. This is your rectangular form for that polar coordinate. So generally, you guys can use this formula. You can say the x equals the radius times cosine with the theta, and the y equals the radius times sine with the theta. So if you are dense and you're having a hard time thinking right now, just write down those formulas and use them.